Here's the truth table with the 2-to-1 multiplexer when you expand it to include the intermediate outputs A and S naught and B and S. Here's an AND gate, it's currently off, but if I switch this one on, it stays off. If I switch both on, it turns on. And if this one is turned back off, it's back off. Here's an OR gate, when they're both off, it's off. When one is switched on, it turns on. If both are switched on, it's still on. And if the first one was switched back off, it stays on. Here's a NOT gate, when the input is off, it's on. And when this is flipped, it turns off. Here's the multiplexer, with everything off, it's off. With this turned on, it's still off. This is turned back off, and this is turned on, it's now on, and it will stay on while that one is also switched. If we switch everything back to off and turn this one on, it'll still stay off. But if this one is flipped, it will turn on. And if we put on A instead of B, it stays off, and then with all of them on, it's on. Here's the multiplexer again, with everything off, the LED is off. If B is switched on, the LED stays off. If B is turned off and A is turned on, then the LED is on. If B is then also turned on, the LED stays on too. Now if S is turned on and everything is turned back off, it's off. If S and B are on, the LED is on. If S and A are on, LED is off. If everything is on, the LED is on. Here is a 4-to-1 multiplexer using 3 2-to-1 multiplexers. Here's the manual multiplexer with S, A, and B. If you put B on, nothing changes. If you put A on, the light is on. If B is also on, it stays on. If just S is on, nothing's on. But if S and B are on, then it is on. If S and A are on, it's off. When all of them are on, it's on. We now have the signal for A and B provided by the Arduino and can change between them by using the selector. It is right now providing 10 Hz or 10 times per second. If we switch it to B, it'll switch to being 0.5 Hz or once every 2 seconds.